Today we are going to discuss data science libraries. One of them is NumPy library. We are going to see how to declare NumPy arrays, and then we will see different operations over the NumPy array, and then we will see how to access NumPy arrays, and then how we can do the different computations over the NumPy array. And after that we will move towards the another library, that is the Pandas. Okay, so hello everyone, this is Sharda from GoEduHub Technologies, and I would like to welcome you again for the session 5 of machine learning training using Python. Guys, please confirm me, am I audible and my screen is visible to all of you? Please just give confirmation in the chat window so that we can go ahead. Some people are joining still. Am I audible, guys? Okay. Okay, I got some confirmations. Thank you so much, guys. So basically, in today's session, as I already told you, we are going to discuss NumPy library. Okay, you know, we have base of Python, and now we are going ahead towards the machine learning because our course is machine learning with the Python. So we have covered certain topics of the Python like Python basic introduction, conditions, loops, string, list, tuple, dictionary, sets, and functions. Okay, and now we are going to start certain data science libraries because these libraries are very important when you are going to implement some algorithm in machine learning. You should have basic knowledge of these libraries. Okay, so we will see first library, that is the NumPy library. You can go to the GoEduHub, then at the hot first link, and there is the machine learning training or that machine learning module, and then we have this NumPy library. Okay, so first question comes to mind is, what is this NumPy and why need this? Okay, first of all, we should know what is this NumPy and why we need it. What are the NumPy arrays? Okay, we have certain fundamentals of the Python. We have arrays in the Python. We have list in the Python. But we need one more different type of library, that is the NumPy. Basically, NumPy is the Python package. And it is basically stands for numerical Python. Let me open this. And you can say NumPy is for the full form. I can say it is numerical Python. Okay, it is the core library for scientific computation, which contains powerful n-dimensional array objects. We can do scientific computations. Very easily with the help of NumPy objects. Okay, and this Python NumPy arrays will provide certain tools for interacting with C, C++. If you want to interact with other languages like C, C++, then we can interact with them with the help of NumPy. Basically, it is useful for doing certain operations like linear algebra. You want to solve certain equations of linear algebra, and you want to solve certain numerical capabilities, probabilities, some scientific calculations you want to do. You can do easily within the fraction of seconds time. Okay. It is multi-dimensional. It is also a multi-dimensional array. Okay. So you can say, you can define this like it is n-dimensional array. Array objects, it is array objects which is in the form of rows and columns. Okay, so basically you can come to this article and you can read these definitions. Introduces objects for multidimensional arrays and matrices, as well as functions that allow to easily perform advanced mathematical and statistical operations on those objects. Okay, it provides vectorization of mathematical operations on arrays and matrices, which significantly improves the performance. And many other libraries are based on this NumPy. You can say NumPy is the base library for most of the data science libraries. Getting, guys? Okay. Okay, somebody is writing, ma'am, can you implement in Jupyter Notebook? Column is same as the Jupyter Notebook. You can implement in the Jupyter Notebook as well. Okay, there is nothing difference. So basically we are studying the NumPy library today, and this is library is base. It is a base library for the data science. Most of the libraries are based on this. Okay, now the question comes to mind, how I can implement this library? How can I install this library? Okay, some of you may be using Python ideally, or some other editor like PyCharm or some other. So you can install the NumPy, pip install NumPy by writing a command pip install NumPy. Okay, and if you are using Google Colab, then you don't need to write anything. There is already NumPy installed. Okay, so if just import the NumPy, and if you are getting any error, then you can import this by writing the command pip install NumPy over your CMD or wherever you are using. In your IDE, you need to write this command pip install NumPy. Here I can directly import NumPy. Okay, NumPy, I can give name as NP, a short name. Either I can remove this part, or I can give a short name as NP. Further, I'll just refer NP in place of writing NumPy again and again. Okay, so let's understand what exactly is multidimensional array. Now we will understand what is the multidimensional array. Okay, so we can, in the multidimensional array, what we can have multiple rows and multiple columns. We can have different items are stored in their respective memory locations, and they are generally accessed with the help of rows and columns. Simple 2D array. Similarly, we have multidimensional array also. Okay, so let me start the NumPy. How I can implement the NumPy? Import NumPy as NP, and then I can declare a NumPy array like A is equal to np.array, and then inside this I can write 1, 2, 3, 4, 5, and then I can print E. Okay, you can say this is a simple NumPy array. I'm accessing a NumPy array. Okay, and basically when you are working over some images, like if you want to talk about the real-time data where we will use these things. Okay, so basically when I talk about a image, a digital image, you can thought that digital image is a kind of two-dimensional array. Like I can tell you, if I talk about an image, I have an image. This image have nothing. This image have certain rows and certain columns, and it have certain pixel values like 0, 144, 255, certain values we have. And these pixel value, what represent the pixel value? Pixel value represents brightness of an image across the area. Okay. Similarly, if I talk about the sound clips, okay, what is the sound clips? Sound clips you can thought 1D array. They are the array intensity versus time. Similarly, we can represent text also into various forms. Text we can represent in numerical form. So whatever the data you have, no matter what is the data you have, first step is we need to making it analyzable. We need to convert that, transform that into the arrays of numbers. So whatever the data you are having, you need to convert that data in the form of arrays. Okay? So basically, whatever the data we have, we need to convert that data in the form of arrays of numbers. That's why NumPy is very important. For this reason, efficient storage and manipulation of numerical arrays is absolutely fundamental to the process of doing data science. That's why we are including this library into the data science. So this NumPy package is one of them that will handle the array of numerical data. This NumPy it provides efficient interface to store and operate on dense data. And you can think about, we have already studied a list. Okay? We have already studied list. NumPy array is just like list. It is kind of list. But NumPy array is more efficient. You can say in the form of storage and operations. More efficient in the form of storage and operations. As far as our array grows in the size, we cannot handle with the help of the list. Okay, so that's why the time we are providing to learning the NumPy array is not wasting your time. It is the more important. Okay, so that is the base of the NumPy array. Why we are using the NumPy array? Now you should have answer for this question. Like somebody asking you, you have list, then why you are going for the NumPy array? I just want to do some data science task and I want to analyze some data. So first I need to convert that data in the form of some numerical, some arrays of numbers. And then how can I handle that arrays? If my data is growing, I cannot handle with the help of the list. I can handle that data with the help of NumPy Array. Okay. So time we are spending to learn the NumPy Array effectively will be valuable no matter what aspect of data science we are going to cover. Okay. And it have built-in documentation. You can go to numpy.org. It is an open source library. numpy.org. Okay. And this is the site. Here you can see the documentation of NumPy. Okay, there are the different things, but moreover the important things which we are going to use, I'm going to cover here. Okay, so you don't need to worry about these things. Simple, I have declared a 1D array. Now I just want to declare a multi-dimensional array in NumPy. Moreover, we are going to use the multi-dimensional array. Multi-dimensional array is equal to np.array, and then inside the braces I need to write, okay, this is help providing the Google Colab. Sometimes it's okay. Inside the square bracket I need to provide values like this: 1, 2, 3, 4, and then one more 1D array, comma separated, and 10, 20, 30, 40. Now I can run this and I can print A. And you can see this is the 2D array. Okay, so one question comes, you should know now the NumPy versus the list. Why we are using the NumPy in the Python? Because NumPy is, in comparison to list, it takes the less memory, it is more efficient and it is more convenient. We can work with the large data easily. It occupies very less memory as compared to the list, and it is pretty fast in terms of execution. It is very convenient to work with the NumPy. So the major advantage of NumPy arrays over the list is it is fast. It is taking less memory. It is convenient. Okay, and that we can see in the real time also. You can compare with the list. You can compare the time, what the NumPy is taking to time and what the list is taking the time. Same thing, one task we will do with the both list as well as with the NumPy array. Okay, now I can check the type of A. It is ND array, n-dimensional. ND means n-dimensional array. And yesterday or day before that, somebody is asking how to I can check the size, how can I check the size of particular variable. So I'm telling that. Prince has written some Python modules, some topics. Obviously, I know some topics left. Yesterday, I have already told you some topics we will cover later on. Okay, so don't worry about the topics, just focus on the class. That is my responsibility. I'm going to cover the things. Your work is just whatever I'm telling you, you have to cover that. You have to practice over that. Okay, so here I was taking, I'll take import already I have taken import numpy as np, and then I'm importing import time, and then one more module here. I'm importing import sys. Okay, now I'm taking a variable s is equal to range of 1000. Okay, and then I'm print size of this sys dot get size of, and then I can write here 5 into length of s. Length of s. I'll explain you, just wait. And then I'm taking another variable d is equal to range 1000, and here I'll print d dot size into d dot item size. Here you can see the memory allocated by the NumPy array is 4000. There is some error, no? D dot size into no attribute size. Okay. Okay, I'll take the NumPy array np dot a range. This is NumPy array. NumPy array have d dot size into d dot item size. Okay, here you can see the NumPy array np. Okay, and I'm creating a variable with the NumPy array that is same size 1000. Okay, that represented by the d, and simple list variable I'm creating with the help of s. So the size, the memory size, memory allocated by the list is here denoted by the s, and you can see that is the 28,000. Whereas the memory allocated by the NumPy array is just 8,000. Now you can conclude this thing, the difference between these two. So that's why we are picking NumPy, because NumPy is taking less memory over the same size of array. You just want to check it out, the type of this, type of s. I need to put it print. So this is module. There is a function for checking this memory size, type of d. Okay, this is simple class range we are generally using for the list, and this is the NumPy array. Okay, so the memory taken by the NumPy array is denoted by this, and memory taken by the list is denoted by this, and you can see the huge difference. So this is a module, that is inbuilt module. it has sys and time as inbuilt module inside the Python. Like we have one library inside the Python is NumPy. Similarly, we have certain libraries. One is the time and one is for sys. It is for the, it have some system modules. Like we just want to use some inbuilt functions for file reading, for the size calculating. So there are the certain functions inside the sys module. Okay, these are the certain functions inside. A range is a function inside the NumPy array. So we will see that later on, but the little bit idea you can get from here, the difference between the memory allocated. Similarly, you can take the time also, you can check the time also. So there are the huge difference between the speed and memory. Okay, we can see the another example for taking the time part. Like we can import the time and then we can take 2-3 numpy array and list, and then we can write certain loops and start time and end time we can calculate, and we can see the difference. Let me write that, or we can go ahead. Rohit, just write your name and college name. We will check it out. Here, I need to change it out. S. Okay. This is integer size, or you can take this simple S. Okay. Okay, let me go ahead. Now we are clear with the difference with the NumPy and this. Now we will check the certain properties, or you can say certain operations of the NumPy. Okay, let me come to here. How to create a NumPy array, we know that. Now we just want to access certain elements of the array. How to access the elements of the array? You can access the elements of the array just like list. Like here I have defined A, this one. Okay, and now I just want to access the elements A of 0 and then A of 1 and then A of 2. It's just like the list. Item size function is generally we are using to calculate the byte size of each element. Like I have used that item size. So to calculate the byte size of each element. Like you can see here, I can do this. Print A dot item size. Okay, I have defined a single dimensional array, and with the help of this item size function we get the size of each element in the form of bytes. And if I want to know about the dimension of this array, a dot ndim. Ndim is for checking the dimension of array. It is a one-dimensional NumPy array. Because here I have defined this array. This is 1D array. So this ndim function, I can find whether array is single dimensional or multi-dimensional. What you are not getting, Sujit? It's nothing. I'm just calculating these are the certain functions. Like inside the NumPy, we have certain features of size and item size. So I'm getting for a particular item, what is the size it's taking, and then I'm multiplying with the total length of the items. And this is NumPy array to declare a NumPy array of 1000 elements. So just wait, in the upcoming steps, I'm going to explain each and every function. And similarly, here we are calculating size of particular list. How much byte it's taken. Okay, so don't worry about these things. These are the certain methods, and these are used to calculate the size of a list. Like get size of is used to get a size of a list. Time and sys, these are the modules. I'm just using this is from the sys, I'm using this get size of method. That's why I have used this module, and time I have not used. Either similarly I can do the sum operations or the list and sum operation or the array, NumPy array, then I can calculate the start time and end time, then I can differentiate which one is the fast. Okay, so don't get confused. These are the simple things. Okay, now come to the array. I'm telling you certain properties or operations over the array, NumPy array, those we can do with the NumPy array. Mohit, don't confuse. I'll explain each and every function in the NumPy. Okay, so just focus on the class. Don't confuse over that code. That is just for explaining you the purpose of how much space both are taking. Right now you don't know the functions of the NumPy array, so I'm telling you the NumPy array functions. So after the certain time you will get to know what is the arange function, what is the item size function. Item size function I have shown you, like I have declared a NumPy array, then I can access the elements like this. If I just want to calculate the size for a particular array, then item, then I can check like this. For an array, item size is 8. Okay, and we can also find out the data type of elements that are stored inside an array. Like we just want to know what type of particular elements inside the array. Okay, so generally it is a homogeneous array, collection of homogeneous elements. So what we write here, a.d type, we can check the data type. Okay, so print a.d type. Okay, data type, you can see it is int 64. You can find the data type of elements that are stored in an array. Okay, so it will print the data type along with the size. Here you can see data type is integer 64-bit. Okay. Similarly, you can find the size and shape of the array using size or shape function. Like here, I can write like this, print, and then I can write a dot size. Okay. So size of the array is total number of elements. How much elements I have inside this array? I have total 5 elements in this array. 1, 2, 3, 4, 5. Okay. Similarly, I can print the shape of the array. A dot shape. Okay. Shape of the array is, it will show you the dimension of the array. Like if we have 2D array, then it will show you number of rows and number of columns. Here we have only 1D array, so it means 1 row 6 columns, 1 comma 6, 1 row 5 columns, 1 comma 5. Okay. So basically, it's a size of a NumPy array. Let's move ahead and we will see certain more features, like we can do the reshape of an array. We can do the slicing of an array. Okay, so let me write here, I'll declare a 2D array. Okay, you know how to declare a 2D array? We need to use this array function. Whenever you are trying to declare an array, you have to use the array function. So A is equal to np.array, and then inside the braces we need to write 2D array. Okay, I can write like 10, 20, 30, 40. And similarly, comma separated, I again write one array. Inside this, I write certain values 1, 2, 3, 4, like this. This is my 2D array. It having collection of 2 1D array. Okay. Now I'll print A, and then I'll reshape this array. I can check it out, the size of this array. Print size A dot size. Okay. Size is 8. 8 means total number of elements. How much elements I have? 8 elements. Similarly, I can check the shape of this array. Print A dot shape. And now you can see shape is 2 rows and 4 columns. Now I'll reshape this array. Okay, so how I can reshape this array? A equals to A dot reshape. There is a function reshape, and inside this I can pass the dimensions, reverse dimension 4, 2. And now I can print A. And you can see I have converted an array from 2 rows 4 column to 4 rows 2 columns. How it's taking the values? Sequentially 10, 20, 30, 40, 1, 2, 3, 4. So we have an array that having the size 2, 4 and which we have converted into 4, 2. This is called the reshape. Endem is used to check the dimensions. Like here I'll use endem. Print a dot endem. It will give you the dimension 2 because my array is 2D array. Now I can check the shape also. Print a dot shape. And you can see the shape is changed. 4, 2. Initially it was 2, 4. Yes, number of rows and number of columns product should be equal to the size of the array. And size is total number of elements. Okay? Now we can see the slicing. Like we have seen the reshape function. Now we will take the another operation, that is the slicing. Slicing is basically we are extracting particular set of elements from the array. Slicing is similar to the slicing we have done in the list. Okay, so we will see an example here. Like a equals to np.array, and then I'm defining the array. Okay, and then here I'm providing certain values like 1, 2, 3, 4. And then again I'm putting here certain values 3, 4, 5, 6. Okay, it is my 2D array. Now I just want to access a single element. Then I can print a of 0, 2. Single element we have accessed. In 2D array, how to access the element? 0, 2. 0 means row and this 2 means column. So 0th row and second column element is 3. Okay? Now what we need, we just want to change. Like we want 2 elements. Print a, and then here I'm writing 0, 2. What does it mean? Okay, so it's providing you 3, 5. It means in the row I have done the slicing. It's started from 0 and colon, after the colon I have not written anything. It means it will include 0 to all the rows. So 0, 1, both the rows I have included, and the column I have included only the second. So the second column we have in first row value is 3 and in the second row we have value 5. So output is 3, 5. Okay, or either I can include one more row here, comma 10, 20, 30, 40. Okay, now I have 3 rows and now I'll write here 2, 0, 2. So this time what happens, it will include only first and second row, 0th and first row. Second row it won't include. If I'll write here, then it will give you the 3. What happened? I need to run this again. Now you can see 0 colon means started from 0, all the rows, we are taking all 3 rows, okay? And column we are taking only the second. So we are getting the 3 elements. If I'll restrict this end limit, I'll provide here 2. It means stop limit never include less than 1, less than we are taking always less than the stop. So 0th and first row it will include, and output is, now you can see 3 and 5. I think now confusion is clear. Okay, some people are asking, ma'am, please repeat slicing. Okay. In the slicing, what I'm doing here, like these are the rows. I have 3 rows and 4 columns. Okay. I just want to access a particular element, then I can write this. First is row. Here I'll comment it. Hash A, and inside the brace is row, comma, column. Okay. This is the way. And if I want to access more than one element, then what I can do, A, and then row slicing, comma, column slicing. Okay. So here I have done only the row slicing. Column I have taken only one. I can also do the column slicing also, like 2, 4. Then what will happen? It will give you a sub-array. 2 rows, 0th and first, and column is second and third. Second and third is these 2 columns. So 3, 4 and 5, 6. From first row, 0th row, it will take 3, 4, and then from first row, it will take 5, 6. Okay, I think now it should clear to you. Okay. So let me go ahead. This is the slicing part, and there are some other functions available in the NumPy, like a range, len space. There are the max, min, lots of functions available. So we will implement some of them. Okay. So like a equals np dot len space. And then I'm writing here 1, 3, 10, and I can run this. Here it will return the numbers evenly spaced over a specified interval. Like what we are doing here, we are generating, like you can print a, we are generating here the 10 numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We are generating 10 numbers in the interval of 1 to 3. So equally spaced, it will generate 10 values between 1 to 3. Okay. We are generating the 10 numbers between 1 to 3. Similarly, there are some other functions like minimum function, max function, sum function. We can use them also, like print a dot min. Okay. I can print the minimum element from this A array. Minimum element is 1. And similarly, I can print the maximum A dot max. You guys, please do along with me so that you will get the practical things. A dot max is 3. What happened? A is different. Okay, I have generated the new array. New NumPy array A. So from this array, minimum value is 1 and maximum value is 3. Okay, and then I can print a dot sum. Okay, sum of NumPy array elements. Okay, so this is the simple thing. These are the certain simple functions we have used, certain properties of the NumPy. We have seen not all of them. There are the lots of functions inside the NumPy. But with the help of these basic things, you can do the more advanced task. Are you getting the things till now? Guys, just hit the thumbs up button below the video if you are getting the things of the NumPy, why we are using NumPy, what is the NumPy, all these things we have discussed till now. Hopefully you are getting. Okay. So next thing is, like, we have one more important feature that is called the axis. Like, let me show you. We have certain values. This is a 2D array. 10, 20, 30, 40, 50 and 60. I have certain values. We have a NumPy array that having values 2, 3. Sorry, 3, 2. We have 3 rows and 2 columns. Three into 2. Okay. So here one keyword we will use axis. So basically axis is like this. We have row axis and we have column axis. When I talk about the row axis, then we take always axis is equal to 1. And when I talk about the column axis, then we take axis is equal to 0. Now you are thinking about what is the use of these axes. Like, we just want to calculate the sum of all the columns. We just want to calculate the sum of here and sum of here. We want 2 sum only. Like, what is the sum here? 90 and here is 120. Or either I want sum row wise. 30, 70 and 110. Then we will use the axis. Okay. So we will do this example practically. You can see here implementation part. Like here I'm defining an array A equals np.array and then I'm taking a 2D array. It's a lots of help. (10, 20, 30) and then I'm putting here 20, 30, 40. Okay, this is my array, 2D array. A dot shape is, you can see, 2, 3. Okay, I have 2 rows and 3 columns. Okay, I just want to sum of all the columns. Then what I can do here, print a dot sum. Okay, and then inside the sum function I can pass axis. Axis equals to 0. It means column wise. It will do the column wise. And how much columns I have? 3 columns I have. So first column sum is 10 plus 20, it's 30, and second column sum is 20 plus 30, it's 50, and then 30 plus 40, it's a 70. So I want to do certain operations column wise. Similarly, if I'll replace x is 0 with the x is 1, then it will do all the operations row wise. Okay, now you can see the sum row wise. Okay. Similarly, we have certain functions like square root, we have standard deviation, we can do the addition operations, we can do the vertical and horizontal stacking, we can use certain special functions like arrange. So let me show you. Okay. Print np dot square root sqrt of a. Square root of every element. Similarly, I can get print, and then I can write np dot standard deviation. I can calculate standard deviation of every element. Total means all the elements. Like how much each element is varies from the mean value of the NumPy array. Okay, so these mathematical calculations we can do easily. This A, you can print A. What are the values inside the A? We have this array. Similarly, we will define one more array B. B equals to np dot array. Okay, and then I'll define certain values like 1, 2, 3, and then I'm defining the values like 3, 4, 5. This is my array. 2 rows, 3 columns, both having the equal dimension, A and B. Okay, B I can print here. A and B both having the equal dimensions. Now I can do the certain calculations like certain operations like subtraction, multiplication, division, addition. I can do these operations easily. Like print A minus B. I can similarly print A into B. Element wise, it will do all the operations element wise, A into B. And similarly, I can print A divided by B. Okay, so these are the certain operations I have done. Okay, and now I just want to convert a 2D array into 1D array. So there is an operation ravel, R-A-V-E-L. I can convert that a 2D array into 1D array. Like this, my A array is 2D array. And now I can print A dot RAVEL. This is the function. Okay. Now this is my 2D array converted into 1D array. Okay. So these are the certain functions we are using in the NumPy array. Okay. Now let me come to the article. I don't remember all the functions. So let me revise from here. We have done created array, 1D array, 2D array, and now we know how to access the array. Shape feature we have already seen. Indexing we know how to access the elements, and then slicing we know that. Okay, and then you can check. These are the simple things. Okay. Mathematical operations we have done, and similarly we have certain functions also. np.add, you can use this function also, like simple thing we have done, plus operator we can use, or we can use the add function. Similarly for minus and for multiply and division and square root, we have done all these things. And some x's we have seen, x equals to 0 and x equals to 1. Both things we know. X is 0 is for columns and x is 1 is for rows. Okay, so row wise and column wise we want to do the calculations. And there is, I think, one more article. Let me go back. Yeah, this is only the basic part. Okay, so we have covered all these things, and certain functions maybe I have left out, that is a range array. A range also we can see what is the a range. Like let me create here a function np x equals to np.arange. Okay, and it will create certain values, like started from 0 to 20, and then I'm taking the difference of 2. Print x. What's happening here? We will generate certain values in between 0 to 20 with the difference of 2. Okay, so a range will create an array in NumPy array that you can specify certain values, like I just want to generate certain values in between 0 to 20. Okay, and we can also write like this: x equals to np.arange, and then here I'm writing 20, then it will generate 20 numbers. Equally spaced. Okay, so basic functions, ndim, shape, and then size, and then dtype, then item size, these things we have seen. We know how to create an array and then how to access an array, and there are the certain functions also I remember. np.zeros. Okay, I just want to create an array of size 3,4 with zeros. Sorry, what happened? Okay, I need to write one more braces. Its size is 3,4. I'm creating an array of zeros with 3,4 size. Okay, similarly I can create an array of ones, np.ones. Okay, and inside this I can write the values like this: 2, 3. Okay, and you can print a. So it is an array of 2 rows, 3 columns containing value 1. Okay, so a range you got it, zeros you got it, ones you got it, and linspace we have seen. Okay, so these are the certain functions, and reshape also we have seen. Like when I have written np.arange, print np.arange, and here I have written 1000. What does it mean? It will create 1000 numbers array. So that's why I have used 1000 when I was checking the size. Okay. And some universal functions we know, indexing and slicing we know, iteration we know, multidimensional array we know. So these are this, I think, basic things we have covered. And we can also change the shape of the array, like we want to change from 2D to 1D, then we can use Ravel function, and Reshape we can use. Okay. Now I think NumPy is almost, we have covered everything. Okay, so we can go ahead towards the next topic. Prince is asking a question, ma'am, I didn't get linspace. Okay, so linspace is basically like you are generating certain values with a certain interval. Like I have this one. I'm generating values in between 1 to 3. This is the range. And 10 values I'm generating. So it's generating 10 values in between 1 to 3, equally spaced. Okay, and if somebody have written linear algebra is left. Okay, linear algebra is just like you can calculate the transpose. Like I have taken an array A and I can do some linear algebra operations, like A, you can print what is the A. A is this array, and otherwise I can take another array A. Yeah, this B array I'm taking, I'm running this code. Okay, and here I'll print B. Okay, and then I just want to get the transpose of B. So B dot transpose, there are linear algebra functions already available in NumPy, so I can get the transpose of this. Similarly, linear algebra inverse I can calculate. Like I just want to calculate the inverse of this, then I can use the some function lin a lg, first one, and then I have inverse function, inverse of B. Okay, it should be square array, because inverse, if you want to calculate in the maths, then it should be a square array. So kind of operations of linear algebra you can do easily with the help of NumPy Array. Now it's enough. We will go ahead next library, that is the Pandas. Now guys, can you please give me a quick confirmation? Are you getting everything regarding the NumPy Array? You should know how to access the NumPy. You should know the difference between NumPy and list. You should know different operations over the NumPy. Ravel means you can convert 2D array into 1D array. Okay? Now come to the next library, that is the Pandas. Can you please explain once again? That is the simple thing. Like B is this, B is this array, and then B dot ravel. Now you can see, now my new array is converted from 2D array to 1D array. Okay? So I just want to convert from 2D array to 1D array, then I can use ravel. Okay guys, enough? Yeah, flatten also we can use. There are the lots of functions available. I cannot say I have covered all the functions, but the most commonly used functions, I'll try to cover all of them. Now come to the next library, that is the pandas. Okay, I'll give you the brief introduction about the pandas. Pandas is mostly used for the data analysis. Like when I talk about the pandas, it means I'm going to handle certain files. I have certain one-dimensional data or two-dimensional data, and I'm going to handle with the help of pandas. It is kind of analysis of data. You have some Excel sheet and you just want to get out, like you have Excel sheet of marks of all the students, and you just want to get out who are getting the maximum marks and who is getting the minimum marks. Kind of operations you just want to do, you can easily do with the help of pandas. Like these things you can do with the help of SQL also, but in the case of SQL, what you need to do, you need to create certain tables, then you need to store the data. But in the pandas case, you can directly access the file, you can do the operation over the file directly. You don't need to store anything. Okay, so basically pandas provides a tool for data manipulation, reshaping, merging, sorting, slicing and aggregation. You can do these type of operations with the help of pandas. Okay, basically, and we can also handle the missing data with the help of the pandas. Like what is the missing data? Missing data is like you have a Excel of certain data sets, and inside that data set, in some columns, in some rows, there is no value. Okay, there is no value available, there are the certain nulls available. Then for that we have to first handle the null values, and then only we will do a certain operation over that data. Okay, so this is the thing we will handle with the help of pandas easily. Or you can say pandas is generally used for the data manipulation. I can write here. What is the pandas? Okay, it is generally used for the tabular data with heterogeneous type of columns. This is a library based on the NumPy, and we use tabular data with heterogeneous type column. Okay, we can use pandas with the ordered and unordered time series. Okay, we can use pandas for unlabeled data. We will see what are all these things. Okay, Now the point is how to install the pandas. It is similar, like we need to write one command only, pip install pandas. If you are using Jupyter, you don't need to install because in the base they have pandas. Like Anaconda, in the Anaconda Jupyter, in the Google Colab you don't need to install. And in other editors you need to install, then you need to write simple command pip install pandas. Okay. So what type of operations we can do with the help of pandas is simple. I can write here operations. Or I'll open the new one. Pandas operations. What type of operations we can do with the help of pandas? In general, I can categorize like slicing, I told you, slicing of data. And then I can say merging and joining. Why we are doing these libraries? Because these libraries will solve 50% of our task in the machine learning. We will do with the help of them, because when you are doing some machine learning, first what you need to do, you need to analyze the data. Whatever you have, you need to see that data in the proper format or not, that data having some missing data, I need to tackle that data first. And I have certain images, I need to convert that images in numerical form. For that we need to use the NumPy. Okay, and handling missing data we need to use the pandas. So for all these things we are going to use these libraries. Okay, concatenation, and then I can say changing the index of data, and then column headers we can change with the help of this. Or we can some other operations with the data, sorting, filtering, all these things we can do with the help of pandas. Okay. There are the different types of pandas. Like one is 1D array, and we have 2D array, and we have 3D array. Basically 1D array is called series, and series is collection of homogeneous array, homogeneous data we have in this. Okay. And if I talk about the data frame, whenever I'll call this word data frame, it means I'm talking about 2D labeled heterogeneous array in pandas. Like whenever I'm using a 2D array, heterogeneous means it can contain multiple types of data, multiple types of columns. So data frame is basically we use for 2D arrays. And series we used for the 1D array, and in the series we always have homogeneous data. Similarly, 3D arrays we generally use panel, okay, in pandas. These are the convention of arrays in panda. And there are the certain popular attributes, like when I'm creating some data frame in pandas, then I'll use certain attributes like data type, empty, size, values, head, tail. I'll use some of them functions somehow. Okay. So what I can do with the pandas, and for the pandas we need the NumPy. So Pandas library is built in on top of NumPy, means Pandas needs NumPy to operate. Okay, so we can declare a NumPy array and then we can use that NumPy array. That NumPy array we can convert to the pandas. Okay, guys, this is the basic introduction. What is the NumPy array? What is the pandas? Okay, still I have not done any implementation part. I'm just trying to tell you the uses of pandas. Okay, and I think today I'm not going to do the implementation part of the pandas. Today I'll only give the introduction, and from tomorrow onwards I'll do the implementation of pandas. So I think this is enough for today. Just after the class, please practice for the NumPy array. Just practice all the functions in the NumPy, different combinations, different things you will do. And then we will do the pandas implementation tomorrow. Okay, so till now, if you have any question, you guys please ask me. Little bit 5-10 minutes early I'm today ending the session. I have some urgent work, so that's why I have to go. And if you have any question till now, you can ask me. Otherwise, I'm assuming you are getting each and everything. Like the first library we have done in the data science, that is the NumPy, and then we have seen the basic intro of pandas. Okay, thank you so much, guys. Okay, bye bye, good night. We'll see you tomorrow.